Okay, so once you've got into Circuit Wizard, this is the screen that you'll see. And we're going to create some circuits in here, test them and run them and see what happens with them. So to start with, if you want to come over to this side of your screen where you've got this gallery tab here and just click on that. And then right at the top here we've got this drop down menu. If you just click on that, that'll give you all of the folders with all of our different components and the component image there also. So it doesn't matter what I go to, there's always your components in there ready to go. So to start with, we'll just create a simple circuit and I'll show you how that actually works. So if we can go up here, we're going to go to power supplies and we're going to grab a 9-volt battery. So to get your component over into our page here, if you just click on it and drag it across and place it on your screen there. And we're also going to put a switch. We're just going to use this push to make switch. Put that in there, and then we'll just get a light emitting diode or an LED, which is here. We'll grab that one and we're going to put it here. Now you can see when I first put the component in there, it's purple. If I click away, it'll go dark blue. If I want to select it again, if I click on it, it goes purple. When it is purple, that's when we can actually rotate it to get it facing a certain direction. So if we go Control and R, you can see that that spins that around. Now you see with the battery, we've got our little positive sign here. That means that's the positive side of the battery. Our electrons are going to flow out of that side of the battery, so we need to have our circuit created in a way that the electrons can flow around in a clockwise direction like that. On your LED down here, you can see that there's arrows on there. We need to get those arrows pointing in the right direction. So if we click on that one, Control R it around. All right, we've got our components in the right area there. Now what we need to do is actually just link those up. So if we hover over one side of your battery, you can see that you get that little pink square with the 4 arrows. So do that, click on it, and you can go across until you get the same on the switch. Then we're going to go to the other side of the switch. Select that, I'm going to click down here, go across, join that up with my LED, and then just link up the last one here. Now we've completed our circuit. You can see that that's full, it's linked up the whole way around. So to actually test it to see if that's going to work, if you come up here you can see we've got play, pause and stop is selected at the moment. If we just click on play and select that, hover over our switch, left click, and you can see that our LED is working when we hit that switch. So that's how we create a really simple circuit. Alright, now what we're going to do is just make our circuit a little bit different this time. So I want you to press stop up here. This one here, you can see here is our delete button, and that's our just our select tool there. So if we click on delete, anything that I select will now just actually delete. And if I want to go back and not delete anymore, we'll just click our select tool there. What we're going to do is, this time we're going to grab a flashing LED, and we're going to bring it across, bring your normal LED down so it's out of the way. Bring our flashing LED across, we're going to Control R that around so it's facing the right way, and we're going to link it back up just like we did with our LED just before, just to finish off that circuit. Go back up here, hit play. And we can see when we now hit that, that our flashing LED is flashing. Now what's happening there is there's a switch, automatic switch inside of that LED, which is just switching on and off. Now that's just automatic. As soon as there's power to that LED, that switch activates and just goes on and off, causing that LED to flash. Now what we're going to do is we'll just hit stop. Delete, we're going to take that line there out, we're going to hit select again, we're going to move this one up here, we're going to link this back up, and like that, hit play, and we're going to hit that. Now what you can see this time is both LEDs are flashing. And so we can see our normal LED, which we used just before and it stayed on, is now flashing. Now what's happening is as our electrons are flowing around our circuit in a clockwise direction, when they get to our flashing LED and the flashing LED switch activates, when that switch is open causing a break in our circuit, that causes a break through the whole circuit, and so it stops power moving, and that's what causes both of these LEDs to actually stop. Now what we'll do is just something a little bit interesting here. If we hit stop, and delete, and we take out that line and that line, select again, we're going to move this LED down to here, we're going to link this back up again, and then what we're going to do is join this up like this. Hit play. Now what you can see is happening here is our flashing LED is still flashing, but our normal LED is just staying on like it did before. Now this kind of circuit is what we call a parallel circuit. So we've got one here and then another one which is parallel down here. What's happening is as our electrons come out of our battery, they're going to flow through the switch, come down here, get to here. Now some of our electrons will go, oh, you know what, I'm just going to go through this way, through this flashing LED, and they're going to keep going around in that circuit there. Some of our other electrons are going to come down here, get to this point and go, no, you know what, I'm going to head down this way and go through the normal LED, and they keep doing that. And that's how this one is able to then stay on, and this one obviously keep flashing like it did. Alright, so that's called a parallel circuit. Before, when we had it like this, let's go back and do that one again. So I'll move that one up here, link that one back up. When we had it like this one before, that's called a series circuit. So our components are all in the one sort of line or the one track. That's called a series circuit. When we line them up alongside down here, that's called a parallel circuit. Now what's interesting about series and parallel circuits is this. If I delete that and I move this one out of the way, and let's say if I put 1, 2, 3, 4, 5, 6, 7, 8 LEDs, and if I just go Control R, let's Control R these all around, so they're right way. Let's keep getting these all lined up. Alright, and then what I'll do is I'll put them all in a line like this. One down, and last one. And then what I'm going to do is I'm going to link these up. So we're going to put them in a series circuit, so they're all in the same track. So just go through and link up these last ones. Like this. Okay, now if I hit play, now you can see that that's not working. Alright, so before when we had one LED in there, that was working fine, but now with 8 LEDs, it stopped working. Okay, now if I hit stop up there and delete, if I take out that line and one of our LEDs, and then I'll link it back up again, let's see what happens now. Hit play. Okay, so you can see if I take an LED out, the LEDs are now, the rest of the 7 LEDs are working, but you'll notice that they're a lot duller than what they were before. They're nowhere near as bright. What that means is we're getting what we call voltage drop. So as our electrons come out of our battery at 9 volts, they're going to go through the switch, and as they get to here, they're going to go through this first LED and they're going to be going okay, but they'll lose a little bit of voltage, keep coming along, hit the next LED, lose a little bit more, hit the next LED, lose a little bit more, hit the next LED, lose a little bit more, and so on all the way down the line. And by the time they get to the end, they're really tired. And so they're way below those 9 volts when they get to there. With 8 LEDs in there, that's taking too much power, and there's just not enough power for those electrons to get back. But with 7, you notice there is enough just to make it get back and keep going around. They're just not as bright because they're not running at that full 9 volts the whole way through the circuit. Now what's interesting is, so that's a series circuit. If I take out that line and then all the ones in between here, where are we? Yep, there and there. Now if I put these LEDs into a parallel circuit like we used before, I think we might find something interesting might happen. Okay, so if we link this one back up, And then if we just go do the same on this side. Yep. Now if I 1, 2, 3, 4, 5, 6, 7, if we make it 8. Now remember when we used 8 before in a series circuit, it didn't work, so it wouldn't even turn on. Let's see what happens if we do 8 LEDs in a parallel circuit. So we go play and hit switch. You can see not only are they all working, they're all working really brightly like they did when we just had the 1 in there, unlike when we put 7 in the series circuit. So what's happening here is our electrons are coming out at 9 volts, coming through the switch, coming down here, and some electrons are going to go through that LED and back around in that circuit there at 9 volts, which allows that LED to work with full power. Some other electrons are coming around here through the switch. They'll come down here, and instead of running through that one, they go straight through that one there, and they run their own circuit like this at 9 volts. So it allows that LED to run full volts, full power, full brightness. Then some others come out, come down, and they skip those two and go straight through that one. So there's all those 9 circuits acting independently to allow each LED to work at its full potential at 9 volts. Alright, so that's, I guess, a bit of a rundown on how circuits work and how we use the Circuit Wizard program. What I'll do is I will set you some circuits to make on your own, and you've got to work out how to make them work properly using series and parallel circuits. Alright.